water bottle difference?
Sure. Yeah. I'm gonna start going over this though. But, yeah. Okay. All right, guys. Let's take a look. Take a look at this stuff. So I started us with everybody's favorite fractions and decimals and percentages. Do you guys remember what the percent symbol means? Yeah. So percent basically means per 100. Literally, it's based on the Latin centum. So when you see a percent symbol, that really is asking you to divide that thing by 100. So the shortcut is, what happens to the decimal place if I multiply by 10? Anybody know? So if I do 7.8 times 10, it just moves over once. Is that cool? Because our number system is based on 10. For some reason, I just don't know why. Okay. If we had 8 fingers, we'd have a number system based on 8. Well, let's not go there. Actually, I do teach that in one of my classes. Right? So this doesn't go into decimal or percent, because decimals are just fractions that fit in our base 10 number system. So if it has a bottom in terms of some power of 10, it can be written as a decimal. It fits into our base 10 number system. So 3/5 doesn't, but of course, what can I do with 3/5? I can do one of two things. I could either, what did somebody do to make this into a decimal? Multiply by 20, sure, or 2. I like you just, so yeah, so you can multiply it until the bottom is a power of 10. Did somebody do it a different way? You could also, of course, what does the bar mean? Divide, right? You could divide 3 by 5. Yes? Okay, I like it. So let's kind of do both ways. So I multiply by, let's multiply by 2. So that becomes 6 over 10, yes? So then that would be 6/10. And just a real quick reminder, hundredths, tenths, ones, tenths, hundredths, right? Get a little lisp when you go math. And then thousandths. The funny thing is the number of decimals you're out is that many zeros. So this would be 4 over 1 with 1 0. This would be 45 over 1 with 2 zeros because it's 2 places out. You guys follow? And I know some of you guys are like, oh my god, dude, this is just decimals. But you know, some of us haven't done this in a while. So 6/10 would just be 0.6. And then to make it into a percent, the decimal is the answer you get when you divide the percent number by 100. So the percent will always be a bigger number. I just said a lot of shit. Let me say it again. The percent number will always be a bigger number because it hasn't been divided by 100 yet. So 7% as a decimal would be 0.07 because it's been divided by 100. It's small. So the way to kind of really truncate that is you move the decimal twice. Which direction you go, watch this. Decimal percent, write that in alphabetical order. So if I want to go from decimal to percent, I move the decimal twice that way. And if I want to go from percent to decimal, I move the decimal twice that way. So from decimal to percent, once, twice, 60%. Okay. Which of course, the guy who told me to multiply by 20, you would have gotten there quicker. Because if you multiply this by 20, you get 60 over 100. 60 per 100 is 60%. Okay. By the way, just notice this, so it's a little concerning. I don't know. Just to make you feel like you're aware of it now, so you're like, can't get your mind up. No.
Thank you for that.
Anytime. Just be careful. I don't like to look at that. I'll have to ask somebody.
Also, this will.
I understand. Yeah, they have in mind. Won't be. What about, so now on this level, how do I go from percent back to decimal? Which direction am I going to move the decimal? Yeah, to the left. Once, twice. So 0.427. Now, what is that as a fraction? What place is that in? Tenths, hundredths, thousandths. So it'd be 427 over 1,000. You're never going to have a problem that's just this. But we use percentages and decimals and fractions in statistics in probability a lot. So you just have to know how to work with them very quickly. What about this? What would this be as a fraction? Good. And I don't care about reducing, to be honest, at the moment. Because you can actually, I don't know if you guys know, but your TI calculator has a fraction button. So if you type in 0.064 and hit the fraction button, it puts it in fractional form, reduced fractional form. And you're all like, where was that when I was doing pre-algebra? And as a percentage, what would this be? Move this over once, twice. 6.4%. Is that cool? All right, what about this? Make that into a decimal. Is it 3? No, your brain says it's already small, but it's too damn bad. It's going to get smaller. Once, twice, so I have to add another 0, so it's 0003. Yeah, tenths, hundreds, thousands, 10,000ths. Yes, 3 over 10,000. All right, is this everybody cool? I think most of us should be okay with this. This guy. 1.12, 1.12. What is that as a percent? Let's do that first. 112%. 100% is 1. So anything over 1 is going to be over 100%. What about as a fraction? There's 2 different ways to do it. What place is this in? So I could do 112 over 100. Or I could do 1 and 12 hundredths. These are the same thing. Just to remind you guys, how do I change from, what do you call this kind of number? Mixed. I like it because it's part whole and part not. And this, of course, is improper, right? So to go from a mixed to an improper, you take 100 times 1 plus 12. You guys all with me? Okay. Okay, I like it. Real quick, because I just can't let it go. I don't know if you guys know this about me, but I'm a math teacher. Do you know why? I know. Do you know why you just do 100 times 1 plus 12 to make it 100 times 1 plus 12? Do you know why that works? Why? Why does it work? Yes?
Because 100 over 100 equals 1.
Good, because what is this really? This is one of the most unfortunate decisions we've ever made in mathematics. Some of you guys are like, well, making it in the first place. Be quiet. What does that really mean? 1 and 12 hundredths. That actually means 1 plus 12 over 100. You guys, and it's one of the most important, because what does it mean when I have 6x? What's the operation between 6 and x? 6x. Multiplication. We all know when something's sitting next to something else, they're multiplying. There's something sitting next to something else, and it does not mean multiply. Right? So it's an unfortunate choice that the old white dudes in power way back when decided before we were around to say anything about it. So if I'm going to add these two together, I've got to get like denominators, and like you just said, 100 over 100. So 100 times 1 is getting like denominators, and then adding to 12 is actually doing the addition. Okay, sorry. Just can't let it go. What about number 2? How do I, this is really a very basic probability thing. I always get somebody tell me the answer is 8%. I like to look around at people's faces to see if they got that answer. You don't have to tell me if you got 8%. Can somebody see what they did wrong if somebody got the answer 8%? Anybody see what they did wrong? What'd they do? Sure, but they did what? True, so if somebody said 8%, what did they do wrong? They did 40 divided by 5. Because their brain said, I can't do 5 divided by 40. So the brain turned it around, and you're like, hey, it's a number. So percentage is always part divided by whole. So like you said, it'll be 5 out of 40. Jeff, 5 out of 40. Which is 1 over 8. That's right. What is that as a percent, though? Well, what is that as a decimal? Here's a really cool way to do this. What's 1/4? as a decimal? 1/4. We all know this. 0.25, yes? 1/8 is 1/2 of 1/4. What's 1/2 of 25? So 0.25 becomes 0.125. So as a decimal, that's 0.125. I appreciate it. Even if you're just playing with me, I love it. So 0.125, and as a percent, what is that? 12.5%. Okay. What about these? Did I actually start recording? I did. That's always helpful. Don't worry about the fat R at the bottom, right? Affectionately called the fat R. That's sigma, or the little weird U with the extra leg. How do you solve for x? What sucks the most about that equation besides it exists and I ask you to do it? What sucks the most? Good. Okay, the Greek letters. So let go of those. Greek letters are just symbols. They're just placeholders for numbers we don't know yet. What is it specifically about that makes it worse than it could have been? Okay, non-understanding is a really big thing that would make anything suck. The fact that it's a fraction, yes? Right? There's the top and the bottom of this thing. So the great thing about solving equations is there a part of it that you don't like? You can very often, I teach a very Game of Thrones-ish math. You can kill the thing you don't like. So we don't like that fat R. It's on the bottom. It's making a fraction. We don't want the fraction. So what do we do to both sides to kill that? Sigma. Multiply by it. I love it. So if I multiply both sides by sigma, I'll get z times sigma is di x minus the mean. X minus mu, sorry. And then I'm one step away from getting x by itself. What's the last thing I have to do? Add mu. I love it. Everybody say mu. Everybody just say mu. Mu. Say it. Mu. What the hell? You know, like, I'm here, man. You're not gonna get me. Okay, fine. X equals mu plus z sigma. That is an actual, those are both formulas we're gonna use this semester. In fact, the other one is also. Those are formulas you're gonna see later this semester. By that point, hopefully you will understand what the Greek letters represent, so you'll know which numbers to plug in the right place. Number 4 sucks a little worse for a couple reasons. Where is the variable that we want to get alone? Where is it? It's in the denominator and it's in the square root. It's got 2 things. So we want to free it. We want to get it free. So the very first thing we can do is get it out of the denominator. So how do we get it out of the denominator? Out of the denominator. What's in this? I'm gonna have some more. Oh, that's good. All right. How do I get that out of the denominator? No, that's how I get it out of the square root. How do I get it out of the denominator? God, you say denominator enough, you sound drunk. Multiply by it. Same thing we did over here, basically. So if I multiply both sides by the square root of n, then I can divide by e. Do you see how we now have the thing that has n in it by itself? Now what do? Last thing I do? Square it. Now you could have squared first. There would have been no real problem with that. It's just a little bit easier just to get this by itself and then kill the square root. Right? Free the n. So you get n equals z times sigma over e squared. And that will mean something to us in chapter 8. Right now it's just a bunch of variables that we played with. Okay. I love the reactions. Okay. Is that all right? I mean, again, I know somebody whispered to me earlier they haven't had algebra in like 7 years. I know some of you guys haven't had math in a while. Got to shake the rust off a bit. There will not be a lot of algebra. I just put this on here to help you kind of like dredge up whatever memories you can get to kind of like get the math gears going. Number 5, and I know I said you couldn't use a calculator, too bad. No. How do I get the average of any group of numbers? Add them all up. So what do you get when you add these all up? 39. And then divide by how many there are? 11. quick little tip on divided by 5 if your jerk teacher doesn't let you use a calculator. If I double the top and bottom, I'm dividing by 10, which is always easy. Divided by 10, you just move the decimal back one. So if I double the top and the bottom, then I just move the decimal over, I'm done. Or just type in your calculator when I let you use a calculator, right? Why do I feel good about that number being the answer? Why does that number make sense? Where should the mean be for a set of data? Somewhere in the middle. It doesn't have to be perfectly in the middle, because one of the numbers could have been like really big or really small, but it should be in the middle of the data somewhere. So that number makes sense. If you would have gotten 16 as the mean, you immediately know that's wrong. Don't turn that shit in, right? Try to figure out what the hell you did wrong. If you can't, real quick, if on a quiz you get something that's obviously wrong and you don't see why, just put, I know this is wrong, I can't see why. Do you understand what I'm saying? I might give you 1 extra point for at least noticing, right? If you tell me that somebody's -3 feet tall and you just circle that shit and give it to me, that, I'm worried. I don't know what that means. Where are they? They're the upside down. Okay. Sorry, I'm finally finishing the last season of Stranger Things. What about number 6? I saw somebody in the front row had a very cool way to do it. How did you guys, did anybody try out number 6? Yes, how'd you try it out?
Well, first, I looked at what the average was.
Oh, of the grades tests you've taken so far?
81, yes.
Okay.
Yeah, 82 and 71. And they equal 153, and the average was 76.5.
Okay.
And you want the average to be 80, so I took, so you want there's 3 tests, so I took 80 times 3 equal.
Oh, okay. I see. All right, yes. And then where'd you go? How'd you use 76.5?
It's equal 240, and then I subtracted 153. And
Oh, okay.
the last one.
Good. So you didn't use the 76.5 at all, right?
Nope.
Good. I was worried when you said you were calculating because you don't want to use that for anything.
Yeah, I didn't use it.
All right, so real quick. He did basically what I saw up here. How do I take the average of any 3 numbers? What do you do? Add them all up. Divide by 3. I love it. I have 3 numbers up there. I do. I know 2 of them, and the third one I also know, but it's algebra knowing. What do we do in algebra when we don't know the value of something? We just call it X, kick ass. And then we pretend like we know what the hell it is. We do that shit so then we can actually do what we know. You just told me you want to add them up. Well, I got to call the third test something. I don't know what it is. I'm going to call it X. So one way to do this is to take, you got 82, 71, and X. Those are my 3 test grades. So how do I average them? I add them up and divide by 3. And I know I want that to be 80. And now that's a little equation to solve, right? And then of course, you, like we did on the first 2 problems, you just multiply by 3, get the division part out of the way. So that's where the 240 came from. Are you guys all with? Anybody else did it this way? A few of you guys? Okay. Some of you guys are like, I just looked at blank because I knew we were going to do it. So you get this, and then you just have to subtract 153. Right. And then you get 87. That's right. Yeah. All right. Now, let me show you a different way to do this. This is my favorite way to do this problem. And yes, I have a favorite way to do that problem. 82, 71, something, yes? How far from 80 is 82? It's up 2, yes? How far from 80 is 71? Down 9. So far, how far away from 80 average am I? Down 7. So then my last number better be up 7. Same answer, right? I know, Cam. I love it. Oh man, you're all like, I love the facial expressions. That's kind of cool. I mean, it's just, it really is based on the idea. If I tell you I have 3 numbers that average to be 10, do you know what any of the numbers are? Do you know what any of the numbers are? No, but you do know one thing. They all add to be what? If 3 numbers average to be 10, they must add to be 30. So let me go one step further. How many numbers could we just make up? You can just make things up. When do you have to get serious? Like, you can make the first number anything, and you can make the second number anything, but then the last number better make the sum 30. So do you see, if I have three numbers, this relates to statistics. This is going to be a huge part of stats. So I've never done this before. I just want to throw it at you right now. If I know three numbers, average to be 10, how much freedom do I have to just make shit up? Two of them I can just make up total. The third one better be what makes the thing add to be 30, yes? So if I have three numbers I don't know, how much freedom do I have? 2. So in statistics, there's something called degrees of freedom. That's what it relates to. That's why we'll see that degrees of freedom is n minus 1, the number of things minus 1. Gonna come up later. Just felt right to put that right there. Okay. Any questions? We did this a little bit fast, but it should have been kind of a review. Any questions on this stuff? No. Okay. So let's get to the really exciting stuff. We're going to talk about some definitions. Finally, the AC is catching up, I think. You guys feel it? Okay. All right. So everybody, remain calm. I never ask you like a straight vocabulary question. I never say define population. What I want you to do is use it correctly. So if I say identify the population of the sample, I just want to see you identify the things correctly. That tells me you know what they mean and you know how to use them. I never ask you just to define some word, right? So the way I like to try to do this, by the way, I'm teaching another stats class later. It's gonna trip me out because I'm gonna be like, I talked about all this already. The way I like to try to do this is by telling a little story. So, is there anything you would like to know? For example, here's a really silly example. The percentage of gross month students that smoke. Is there something like that you would like to know about gross month students? Like the average shoe size is 7.2, right? You guys with me? Is there anything you would like to know about gross month students? You know, like, not a damn thing. Do something with that boy. All right, jeez. Anything you'd like to know? No? Yes?
How many transfer
Let me think, how many, what percentage of students enrolled transfer every year?
Yeah.
Okay. Percentage of enrolled gross month. By the way, this is how I write students that transfer every year. All right, that's not a bad thing to know. I like it. Makes sense. So, can somebody tell me what is our population? Now let me make a big deal out of this. What you just said is fine, except for one little thing. If I told you that in the classroom next door, there are fishermen in the classroom next door. Can you guys envision that? Just envision that for a second. Can you guys see that in your mind's eye? Fishermen, right? They're over there. And they're scheming up. Fishermen next door. Okay. Now, if I said in the classroom next door, there are all fishermen. What's happening in your mind's eye now? What is happening with these poor people? How many fishermen are there? And yes, that title is not inclusive of everybody. I understand that. So fisher people just sounds really weird. Fishermen. How many fishermen are there? Are there 20? What do you think? There are, who knows, thousands, millions, who knows, right? So I want to make this point. The population can't be gross month students, because when I say gross month students, you think of like 4 or 5 some gross month students. If I say all gross month students, holy shit, that's every freaking gross month student. Let's not put them all in that classroom. It's not going to be good. You guys with me? So when I ask for a population, it will almost always have the word all in it to really make it clear. So I need to know you know what the word means. So the population in this example is all gross month students. So I'm going to put in blue, specifically, so I should have written this in blue, but too bad. I'm going to put in blue what the specific thing is for our example, and I'm going to put in black the definition. So the definition of population is just the group of things or people you are trying to describe. Let me put one extra word in here, the entire group. Okay. I can tell some of you guys are like getting settled in. You're like, okay, definitions, here we go. So you all came in here, you all know this. You all know what a population is. And you all know the next word I'm going to use. Because if we want to know the percent of the gross most students that transfer every year, and we're just us, correct? We are just us. Meaning, do you have time to talk to every gross month student? Now, it's a lot easier nowadays, unfortunately, because we used to have about 20,000 gross month students. Now we have about 11,000. Okay. But still, do you want to talk to 11,000 people? No, neither do I. So what do we do in statistics when the population is too large to work with?
Sample.
We take a sample, kick ass. I love it. Somebody's like, just say sample, shut them up. Okay. So, can somebody come up with a possible sample I could use?
100 gross month students with enough credits to either graduate or transfer. Or just 100, right?
So, all right, so I was a little worried about this. Do you necessarily have to have a certain number of units to transfer?
No.
In some cases you do. There are these things called associate degrees for transfer, right? Do you think it's impossible to get admitted to a university without getting a certain number of credits at Grossman College? Is that impossible? I love you guys. I don't know. Could you have gone to university directly and not gone to Grossman College at all? So then how many units did you get at Grossman College? Freaking zero. Shit, you know, right? So you could go straight to university without any community college credits, yes? So if you want an associate degree for transfer, when I say that, do you guys know what that is? Associate degree for transfer. So that's something where we set up an agreement between community colleges and California State Universities, where we've identified 60 units for most majors that you take here, and once you get those set, you're guaranteed a spot in the CSU system, and they'll do the other 60 on the other end. That's what that is. You guys sort of with me? But in general, you could get a spot in a university any damn time they want to let you in. You could go there without any community college credits, yes? Okay. So, let's alter this just a little bit. So it doesn't have to be with enough units to transfer, because you could actually transfer almost any time.
500.
Okay. So I love this. Okay. So he said 500 random gross month students, yes? Can somebody be a little more specific? How would you get them? How would you make it random? That is a huge word in statistics, obviously, the word random. I don't know if you guys remember like the early 2000s, the word random, a lot of people didn't know what it meant. That's so random. Do you guys understand? Can somebody tell me, how would I pick 500 gross month students? What's one way we could do it? Okay, I love it. So some of you guys have read ahead a little bit. This kicks ass. Convenience is exactly what it sounds like. If I used you guys as a sample of gross month students, why is that bad? Not that you're bad people. I don't know you. Why would you guys make a bad sample for gross month college? No, there's plenty of people. I understand why you say that, but mathematically, there's plenty of people, believe it or not. Yes? Good. Why are you here? Are you here for certain reasons that other students wouldn't have to be? You guys with me? Stay with me now. You try to stay away from doing anything that would bias your results. What that means is, depending on what I'm looking at, couldn't students who take statistics have a different opinion about something or transfer at different levels or anything like that? You guys with me? The fact that you guys are here, meaning several things. One, you don't have to take online course. You can take face-to-face. Two, you're taking a stats course, which probably means you need a stats course for some reason. right? 3, you're taking a class at this time. Not everybody can take a class at this time. You with me? So would you really be representative of our population? No. You guys sort of with me. So you want to be really careful about how you pick the sample. And just to say something, the number one thing I hope you get from this class, and there's a lot more than this I hope you get, is if somebody gives you a study, or somebody is talking about a study and they're trying to tell you what it says, you need to know what to ask. You need to know how to verify. And so how did they pick their sample? How large was the sample, right? What method did they use? Did they use any control? So forth. So several things we're going to learn this semester. You guys are bombarded by percentages every freaking day. I don't care where you are. It's everywhere now. Aren't you getting like stuff on the Instagrams and the TikToks? I love it. I just love saying it. Sorry. Or whatever the shit you guys use. What do you guys use nowadays? I don't know. What's out there now? Are those old school? Instagram, TikTok? Those are still in vogue? All right. Facebook's, of course, for your mom and dad. No, get away from it. Okay. All right. So what I'm trying to say is the way you pick the sample is crucial. Anytime you see anybody say something about a study, you want to see how did they pick their sample. If it was just people the person knew, screw that study, right? So there have been studies that when people dove a little bit deeper, they went, oh, this whole thing is shit because the sample was horrible, wasn't representative. But it gets out to the media blasts it, and then it's almost too late to try to reel it back in, and it just gets really crazy. So let me go ahead and write down. Let's say 500 Grossmont students. Now let's see, randomly selected. So can somebody come up with a way? Say.
Stand outside of where else, like the counseling and all that.
Oh, the administration building.
Yes.
Stand outside of that.
Yes.
Who's walking on campus at any given moment? Is that a Grossmont student necessarily? Could your sample include people that aren't Grossmont students? Yes. Okay. What do you think is the number one most important thing? If again, going back, why were you guys a bad sample? Are you representative of the population? No. How do you make a sample that is representative of the population? What do you want to try to achieve? You want everybody in the population to have a chance to get in your sample. Does that make sense? If every element or person in your population has a chance to get in the sample, then you're closer to being a really random sample. That's basically the best we could do, right? Let's try to make sure. So, if I pick you guys, that sucks because not everybody has to take statistics. Not everybody can take a class at 12:30, whatever the hell time it started. Not everybody, whatever, can be here in the daytime. Not everybody can take a face-to-face class. So I did not ensure that everybody in the population had a chance to get in my sample, so of course it's not going to be necessarily representative. So, 500 Grossmont students, chosen randomly from a list of all students. We'll just say magically I can get us a list of all the students. Even then, if we had a list of all, now stay with me, I love it, you guys are like, my God, we're in word number 2, dude. Sorry, stay with me. If I had a list of all Grossmont students, right, and I just imagine this stupid big scroll thing, like several lists, right, you with me? How would we randomly select students from it?
You choose every number.
Oh, okay, so one way is I could choose a random place to start, and then I could choose every, like, 25th student after that. Are you with me? That sounds like a good way. Would everybody have a chance then? So, let me make this a little bit better. What if I chose a random person to start at, you, and then I chose every third person? Did everybody have a chance to get in the sample? Anybody shaking their head no, you're thinking about after the fact. If everybody got in the sample, what's the point of a sample? Did everybody have a chance to get in the sample? Yes. If you think no, tell me who did not have a chance. So I picked somebody at random to start at, right? So I picked somebody at random in this first row, right? The 5th person. 1, 2, 3, 4, 5. And then every third person after that. You with me? Before I started picking anybody, does anyone not have a chance to be in the sample that's in this room? Everybody would have a chance, correct? So that is a method that would lead to a random sample. Okay, you guys good? By the way, that method is called systematic, which kind of makes sense. Every n thing it's got a system to it. Systematic, automatic. All right. What's another way we could do it? By lists. So I'm envisioning it. What if I taped all the lists of students to the wall? Couldn't we just take a dart or a marker even, just start throwing it, and then whoever's name we landed on, you with me? All right, that's a classic random. Yes. Ooh, sorry. Very geeky response. Sorry. I love this. So you just did something called stratify. So break them into groups and then take some from each group. Sort of like you're all broken into rows, correct? Yes? You're all like different houses. You have sorted yourself. There's no hat up here, sorry. If I took 5 people from each row, is that random? Would everybody in this room have a chance to get in the sample? If I took 5 people from each row, does everybody have a chance to get into the sample? Yes, I love it. What if I randomly picked 3 rows and took everybody from those rows? Cluster, look at you guys. Little tear coming out. The rest of you guys are like overachievers. So, if I break things into groups, stratified would be taking some from all, stratified, some from all. Cluster would be taking all from some. Sounds very Musketeers-ish, right? Some from all, and all from some. Okay. Maybe. By the way, we're going to go over these sampling methods later. They just happen to be creeping in right now. The important thing is, sample, you want it to be random sample. That's the gold standard for sampling. So a sample, the definition is just a subgroup of the population. So a sample itself is just a subgroup. It's any subgroup. So you guys are a sample of Grossmont students. You're just not a representative sample of Grossmont students. I like it. Okay. Once I've collected, first day, I don't remember how long did we go? 2:35. Okay. I'm gonna let us out a little bit early, so I'm gonna talk about a couple more definitions. So just imagine we've done this. We got a population of Grossmont students. We utilize a method, and we get 500, and we got them all standing in the field, right? A bunch of Grossmont students just standing in the field, looking around like doing the John Travolta thing. What do we do with them? What do we do with them? If you took a sample and you had something you wanted to know, what would you do with the sample? What would you do with each person? What would you do? Ask them a question. I love it. You would ask them something about transferring, right? So the next thing you do, once you got the sample selected, is you ask them a question. So the statistical word that kind of relates to the question you would ask is remarkably, it's awesome, it's the variable. The variable of interest here is the number of students that transfer, right? So if we have 500 students in a field, I'm going to ask them, are you going to transfer? 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 Right? So 3, variable. This is related to the question you would ask. Or in the case of, if you're trying to figure out the average length of a dog's tail, you're not going to ask, hey dog, well how long is your tail? Yeah. So the question you want answered, correct? You don't always ask it because it could be something that can't talk to you. In this case, it's people. It's people. So in this case, the question would be, are you going to transfer? Right? There's some issues with this, but we're just going to go. So the variable would be the number of people transferring. Now, to be really honest, the variable could be, are you going to transfer? I'm just going to change the next thing, but I'm just trying to I've decided to try to line up with the book a little better. So the book would say the variable is the number of people transferring. Once you ask a question, you're going to get a bunch of answers, correct? You're going to write a bunch of answers down. With me? You're going to write a bunch of answers down. What we do with those answers is called the statistic. We're getting there. Don't write that down yet. But the answers themselves, the collection of answers, you already know what this is called. What is it called when people collect from you, like your hair color? Data. I love it. So the answer to the question is called data. So the data, the answers, oh my God, to the question.
Yes, transfer, no transfer.
Yes, I love it. So the book would say, and I really disagree with the book. The book would say this is the number of people transferring. I would say, I'm going to write this up here. What kind of thing are you? I would say, are transferring or not. And so the data for the book would be 20 people, 30 people, 40 people, whatever. But for me, it would be yes or no. So it really depends on the way you identify your variable, what your data is going to be. You guys with me? So we have a group we want to say something about. We have a subgroup we're going to work with, because who's got time for 11,000? Ain't nobody got time for that. We got a variable, which is the question we're going to ask them. We're going to get them together. Why are we going to get them together? So we're going to ask them a question, and then we're going to get a bunch of answers, hopefully, right? So in this case, the answers could either be 20, 30, 40 people, whatever, or it could be yes, no, if you're going to go for my interpretation. I think, what did I say? I said I was going to do two or more. I got to do, sorry. So I already lied to you. Too bad. The word statistic is actually means something. Once we get, let's say that we get a bunch of yes or no answers. Yes? We get a bunch of yes or no answers. What are we going to do then? Going back to what we want to know. We want to know the percentage of enrolled gross month students that transfer. So once I get a bunch of yeses or nos, what am I going to do?
Use the samples or the statistic.
What am I actually going to do? Let's say I have 500 answers and 100 people said yes. What are we going to do with that?
Parameter, is it?
Not quite yet.
Okay.
But what am I going to do with it? Aren't I going to do 100 divided by 500? Get a percentage? Right? Because don't we want to know the percentage? So once we know the answers, yes, no, 500 answers, let's say 100 people say yes, that's 100 divided by 500. We're going to actually calculate, we're going to analyze the data. So the immediate thing we do when we analyze the data is called a statistic. And that's because this is let me write down the definition. A numerical, yeah, Jeff. A numerical description. You can tell I didn't have lunch. Numerical description of a sample. Whereas a parameter is the numerical description of a population. Now, something just happened that does not happen often in mathematics. It happened once earlier, actually. Parameter, population, statistics. You can't beat that shit. Come on, right? So when I ask you, tell me what the parameter is, it better be a number that describes the population. So if you say 71% of all gross month students eat cheese or whatever the hell, right? That's a parameter because it's describing a population. If I say 71% of the 400 surveyed gross month students eat cheese, that's the statistic. Is that cool? Because it describes a sample, that's it. Okay. I think that's enough. It's enough for today. So that's it. So if anybody needs to see me for any reason, come on up. I'm gonna post this video to YouTube. Let's see, did I get everything? Maybe. So it's there if you need it. Otherwise, I will see you guys Wednesday. We'll take a little trip on Wednesday, a little field trip. If anybody came in after the roll was called, let me know.